Before we get started, we'll first understand the various forces which we see in our day-to-day life. Force generated by compressing an object or substance is called a compressive force. It is the force applied outside an object that pushes inward. The tension force is the force which is transmitted through a string, rope, cable or wire when it is pulled tight by forces acting from opposite ends. It is nothing but a pulling or a stretching force. Bending is a force that deflects or bends an object. Torsion is a force that tends to twist an object. Shear forces are unaligned forces pushing or pulling one part of a body in one direction and another part of a body in the opposite direction. A good example of shear force is seen with simple scissors. The two handles put force in different direction on the pin that holds the two parts together. A cantilever beam is a beam supported at one end and carrying a load at the other end. The beam transfers the load to the support where it is forced against by moment of force and shear stress. Moment of force or torque is the tendency of a force to twist or rotate an object. Mathematically, it is the cross product of the force by the distance. Shear stress is defined as a stress which is applied parallel to the face of a material. Shear stresses arises from the force vector component parallel to the cross section. Cantilevers are employed extensively in building constructions and in machines. Cantilever construction allows for overhanging structures without external bracing or support pillars. In building, any beam built into a wall and with the free end projecting forms a cantilever. In bridge, building a cantilever construction is employed for a large span in certain sites. Cantilever cranes are necessary when a considerable area has to be served, as in steel stockyards and shipbuilding berths. Now let's look at two important material properties we'll be using during our coursework. Elastic modulus is represented as Ex in ANSYS. Young's modulus or modulus of elasticity is a measure of stiffness of an elastic material. It is a number that measures an object or substance resistance to being deformed elastically, that is, non-permanently, when a force is applied to it. It is also defined as a slope of its stress-strain curve in the elastic deformation region. Elastic modulus is a quantitative measure of how much something wants to return to its original shape and size. Parsons ratio is represented as PRXY in ANSYS. When a material is stretched in one direction, it usually tends to contract in the direction transverse to the direction of stretching. This phenomenon is called the Parsons effect. Conversely, if the material is compressed in one direction rather than stretched, it usually tends to expand in the other two directions perpendicular to the direction of compression. When a rubber strip is pulled in longitudinal direction, the strip elongates in the longitudinal direction and contracts in the lateral direction. The strain developed in the longitudinal direction is called the longitudinal strain, and the strain developed in the lateral direction is called the lateral strain. Now when we take the negative ratio between the lateral strain and the longitudinal strain, we get the Parsons ratio. It describes the relative change in the lateral dimension of an object when the load is applied in longitudinal direction and vice versa.